Hello and good evening. Welcome back to Wallah English YouTube channel. So I hope everyone is doing great. Until now, we have covered factors affecting your hydrograph. Okay, and in today's class, we are going to discuss some important topics. Very important topic we can say, from which questions have been asked in your GATE examinations directly. So we will discussing those points. Okay, so before starting, everyone kindly comment that I am fully audible and visible to you all. Everyone kindly comment. Then we will start a lecture. Today will be a very beautiful lecture. In this, we are going to discuss about how to evaluate volume of direct runoff. A very important concept from which many questions have been framed in your GATE examinations. Okay, so good evening, dear. Everyone kindly comment that I am fully audible and visible to you all. Everyone kindly comment that I am fully audible and visible to you all. So today is your fourth lecture of your hydrograph. In this class, we are going to discuss how to find effective rainfall depth from your flood runoff hydrograph. We are going to discuss this thing first. Then we are going to discuss volume of direct runoff. After, see, today basically we are going to discuss this topic only and this topic only, effective rainfall depth from your flood runoff hydrograph. Okay, so now we'll start. So first we'll discuss what is, and see, in the last class we have discussed the factors. Okay, basically factors which affect my hydrograph factors which affect my hydrograph, sir, you have already told me, sir, there were some factors. Sir, first kind of factors which were based on your storm rainfall characteristics. Second were based on your catchment characteristics. Okay, in catchment characteristics, sir, you told me about size of catchment area. Sir, you told me about the shape. You told me form factor, shape factor, or what is compactness coefficient, long narrow catchments, broad and short catchments, all the different kind of shapes we have discussed, and how those shapes will affect the shape of hydrograph. We have discussed this. Okay, then in this we have discussed the size, shape, and drainage density was there. Okay, what was the kind of slope we have in this one. Then at last, sir, we have size, shape, drainage, slope. At last we have, sir, what kind of land use and cover we have. Okay, and here in rainfall we have discussed intensity, we have discussed duration, aerial distribution, and all these things we have discussed. Okay, so I hope you have understood the factors which were governing the shape of hydrograph. Now we are going to discuss effective rainfall depth from FRH. This is our first topic. So yes, this is the empty slide here. Yes, so I will tell you how to find effective rainfall depth from flood runoff hydrograph. Okay, so we have 4 steps, and I will show you some questions also based on this, and how questions can come in your GATE examination. We'll discuss them one by one. Okay, sir, so very first step is if FRH is given to you. Okay, listen very carefully. If FRH is given to you, first you have to find DRH. Okay, the very first step is obtain DRH from flood runoff hydrograph. Okay, sir, and how will I do that? See, obtain DRH from FRH by using what, sir? Obtain DRH from FRH by using this formula. That DRH ordinate is FRH ordinate minus base flow. FRH ordinate minus base flow. Okay, now we have to use one concept here. If I have the DRH, sir, if I want to find from DRH effective rainfall depth, one thing we need to understand. Yes, simply delta the base flow. Great answer. Now before moving ahead, we have to understand the concept of volume of direct runoff. Okay, so how volume of direct runoff is evaluated? For this we need to understand that this, let us say this is my direct runoff hydrograph. Okay, let us say this is my direct runoff hydrograph. Sir, what is this? Sir, this is direct runoff hydrograph. No problem, sir, this is direct runoff hydrograph. Okay, sir, basically you need to understand, sir, direct runoff hydrograph has 2 parameters. Okay, sir, direct runoff hydrograph has 2 parameters. Okay, sir. Okay, what are those 2 parameters, sir? What are those 2 parameters? The first parameter is duration of rainfall. We will denote duration by D. Okay, or let me write it in bracket. The first parameter is duration of rainfall. Okay, and the second parameter is effective rainfall depth. See, effective rainfall depth means excess rainfall. Okay, if we have, let us suppose we have rainfall equal to, let us say 5 centimeter per hour, and let us say phi index is 2 centimeter per hour, and let us say this is 2 hours. Okay, so rainfall excess means this rainfall which is in excess of infiltration. Okay, we are interested in this rainfall. So 5 minus 2 is 3 centimeter per hour. 5 minus 2 is 3 centimeter per hour excess rainfall we have, and multiplied by 2 hours. So total 6 centimeter rainfall we have as excess, which will be running off, which will be resulting in quick flow, Okay, so effective rainfall depth or direct runoff depth, both things are one and the same. So I will draw it here. See this excess portion, sir, you have already told me this excess portion will be drawn here, in which this will be indicating the duration, and the area of this bar, just now I have told you how to find the area. Simply what you have to do, sir, p minus phi, or you can say I minus phi t. P minus phi t you can do, or I minus phi into 2 you can do t. Just now I told you the example 5 minus 2 into 2. Okay, so that we get the total runoff depth. This area will be effective rainfall depth, and this is representing intensity of excess rainfall. I will be representing here excess rainfall intensity. I will be representing here excess rainfall intensity. Okay, yes, perfect. So this is indicating I intensity here, this is duration of rainfall, and the area will be effective rainfall depth. So if I want to find the effective rainfall depth area, I can multiply effective rainfall depth intensity into time, and this effective rainfall depth intensity will be p minus phi t. Okay, this you want to find, you can do p minus phi t. Simple. We'll take up different examples with the help of which we will be able to solve it. Okay, so this is your DRH. Okay, now how I will find volume of direct runoff? The concept is very important concept. See, the volume of direct runoff or the quick flow, the volume of direct runoff which runs off quickly and reaches the outlet immediately after the rainfall, just within a day or two, is evaluated by simply finding the area under direct runoff hydrograph. Okay, this area, how we can find it with the help of integration. If it is a triangle, we can find the area. If it is a trapezoid, then also we can find the area. Okay, this is very important concept, very important. Okay, when you will solve previous year questions, you will see that most of the questions are based on this only. So listen very carefully. See, this is discharge, sir. On y-axis we have discharge, and on x-axis sir, we have time. Okay, so this is discharge, this is time graph. Now what this area will be giving me, the area under this DRH, this area thing will be giving me the volume of direct runoff. Okay, this will be giving me the volume of direct runoff, and you need to understand one thing, that volume of direct runoff can also be written as okay, see, this is the basic concept which you have to remember. Okay, this is the basic thing. But one more thing, see, volume of direct runoff can also be written as, see, imagine you have catchment area of area A, and this is the effect of, or you can say this is the rainfall excess depth. Let us say this is the depth of water which is running off. This is your excess rainfall depth. So how you will get the volume of direct runoff? You will multiply what? You will multiply catchment area into this effective rainfall depth. You will multiply catchment area into effective rainfall depth. Okay, you will multiply catchment area into effective rainfall depth. So this is your volume of direct runoff. So now from this we can reach on the conclusion that area under DRH, we can reach on the conclusion. Therefore we can write here that area under DRH, we can find the area under direct runoff hydrograph. Okay, sir. We can find the area under diagram of a hydrograph and put it equal to catchment area. We will denote catchment area by A. Okay, catchment area or basin area will be represented by A from now onwards. Catchment area will be represented by A into your effective rainfall depth. Into your effective rainfall depth. And this effective rainfall can be evaluated by, sir, tell me how I can evaluate effective rainfall depth. So effective rainfall depth means runoff. This means, it means simply your runoff. Okay. This simply means direct runoff depth. This simply means direct runoff depth. Okay. Or effective rainfall depth or excess rainfall depth. This is your excess rainfall thing. So it will be equal to total precipitation minus infiltration. Or you can write it down like this. P minus infiltration is 5 into T. Total infiltration is 5 into T. Let us suppose we have 5 centimeter of rainfall in the catchment. This is our total rainfall. Phi index is 1 centimeter per hour. And let us say rainfall has happened for 3 hours. So you need to understand, out of total 5 centimeter, 1 centimeter per hour water is going into the ground. Sir, 1 centimeter per hour water is going into the ground. So if 1 centimeter water is going into the ground, then in 3 hours, sir, 3 centimeter water will be lost. Okay. So from total 5 centimeters, sir, I will subtract 3 centimeters. So remaining will be 2 centimeter, which will be taking place in the form of runoff. Okay. Runoff will be only 2 centimeter. Yes or no? Okay, dear. Perfect. So this is 2 centimeter. So this 2 centimeter thing is effective rainfall depth. So every DRH, every direct runoff hydrograph which will draw will have two parameters. One is how much is the effective rainfall depth and how much is the duration of rainfall. See, if duration of rainfall and if effective rainfall depth will change, these are basically rainfall characteristics. Okay. Every DRH has basically two rainfall parameters. Every DRH basically has two rainfall parameters. One is duration and the second one is effective rainfall depth. Okay. And based on this, if you will change duration and effective rainfall depth, obviously for a given catchment area, okay, let us say we have a catchment area and duration and effective rainfall depth, when it will change, obviously the shape of the hydrograph will change. Yes or no? The shape of hydrograph will change. So you can say, sir, that my direct runoff hydrograph has basically two rainfall parameters, D and effective rainfall depth, duration of rainfall and excess rainfall, how much runoff will take place. If for the given catchment these parameters will change, then obviously the shape of the hydrograph will change. Okay, parameters mean we'll change these parameters and we'll get the different result, we'll get a different output. Okay, so I hope this is very, very clear to you. So this concept is clear. Now you need to understand, in every question which they have asked you, in every question you will see that they will apply this concept. Okay, we'll solve some questions. So basically 3 types of questions are asked in your GATE examination. Okay, basically 3 types of questions are asked in your GATE examination. Okay, sometimes they will give you, okay, see, this is very important. Now listen very, very carefully for next half an hour, because the types of question which will deal will directly come on your GATE examination for 1 or 2 marks. Okay, so sometimes they will give you triangular direct runoff hydrograph. Sometimes they will be giving you trapezoidal kind of runoff hydrograph. Sometimes they will be giving you you can say a smooth curve like that. Okay, so how we will solve it? We have to discuss one by one. So first case, let us take the first case. Let us take the case 1. Okay, let us suppose sir we have a triangular DRH. Okay, sir, no problem. Let us suppose in examination we are given a triangular DRH. Okay, so how we will solve it? See, triangular DRH is very simple, because basically in triangular DRH you will be given, in triangular DRH one thing is very simple, that area can be found out very easily. Okay, half base into height, area can be evaluated very easily. That's why it is simple. Yes, so it will be like this. Now this will be the base time. Base time will be given as TB. This will be the peak discharge. And this will be the peak discharge, and here we will have duration and everything. Okay. So this will be given to you in triangular DRH. Now how you will find the area? You know the concept. You know the concept that area under DRH, you know the formula, area under DRH is equal to catchment area into effective rainfall depth. Yes sir, I know this. I know this equation from here. Okay, this we have already discussed. So how you will find the area under DRH? Sir, triangular area everyone knows how to find the area of triangle. Sir, it is simply half into base into height, half into base into height. Okay, you can see this is height QP, and this is base TB, is equal to catchment area into effective rainfall depth, is equal to catchment area into effective rainfall depth. So this is the first important formula. So this is the first important formula. Okay, this we will apply. So in this equation, sir, in this equation I can see, sir, four things. Okay, I can see QP, base time is there, sir, catchment area is there, and effective rainfall depth is there. Four things are there. In question, in examination, three things will be given to you and fourth will be asked you. Okay, they will ask you the fourth one. So I hope you can easily evaluate it. Now let us solve one question. Okay, now let us solve one example. Okay, now let us solve an example. So in the question, it is given to you a triangular DRH, a triangular DRH, a triangular DRH resulting from 5 centimeter effective rainfall depth, resulting from 5 centimeter direct runoff, resulting from 5 centimeter direct runoff, a triangular DRH resulting from a 5 centimeter direct runoff. When 5 centimeter direct runoff was there, in that case, okay, resulting from 5 centimeter direct runoff has a time base of 30 hours. That means because of this 5 centimeter effective rainfall, time base of 30 hours was there. Okay, so this is your time base, that is your, okay, has a time base of 30 hours and peak discharge of peak discharge of 15 meter cube per second, 15 meter cube per second. So find the catchment area. So can you solve this kind of question? Find the catchment area. So can you solve this kind of question? This is simple basically. So we can easily solve this if we have a triangular DRH, then we can easily find the area. Can you solve it? Get the answer. See, QP is given to you, TB is given to you, effective rainfall depth is also given to you. Simply find the catchment area. Okay, I'm giving you 1 minute's time and solve it quickly. Tell me the answer. Solve it. Tell me how much you are getting. So if you will solve this, how much you are getting? Tell me. Are you able to solve it? Tell me. Quickly tell me. How much you are getting? No one is getting the answer. One six two zero you are saying. Okay. You are saying 1620. Okay, let me check. Let me check 1620 is correct answer or not. So we will simply apply the formula half. Okay, simple direct logic. Let me draw it here also. Let me draw it here also. See, sir, in this triangular DRH, sir, the peak is given to you as 16 meter cube per second, and the base time is given to you as, sir, 30 hours. Okay, this is 30 hours. No problem, sir. Now we'll simply apply this formula. So half into QP. Sir, QP is 15 meter cube per second. Base time is how much, sir? Base time is 30 hours. See, 30 hours. We have to convert hour into second. You all know that in 1 hour we have 60 minutes and in every minute we have 60 seconds. See, why we have convert hour into second, so that this second and second thing gets cancelled and you get the volume of direct runoff in meter cube. See, this will be the area under DRH. This will be the area under DRH, okay? Which will give you volume of direct runoff. See, in this question, they can also ask you find the catchment area and also find the volume of direct runoff. They can also tell you this thing. So this is representing the volume of direct runoff, simply the area. Area you can find. Area will be giving you the volume of direct runoff in meter cube. Okay, sir, this thing gives me volume of direct runoff. Now equate it to catchment area into effective rainfall depth. Sir, effective rainfall depth is 5 centimeter in question. Effective rainfall depth is 5 centimeter. So you have to convert this 5 centimeter thing into meter. So if you want to convert centimeter into meter, you have to divide it by 100. You have to divide it by 100. Okay. Now you have to solve it. Divide this two thing. Okay. This will be 15. So 15 into 15 into 60 into 60 multiply by 100 divide by 5. So this will be, let me solve it in my calculator. So we will be getting it. Yes, I think you are getting it correctly. Yes, we will solve it and we will get it somewhere around. If you will solve this, area will be 15 into 15 into 60 into 60. Yes, area is coming out to be 1620,000 meter square. Why meter square, sir? Because here it is meter cube, here it is meter, so we'll get the answer in meter square. Okay, when you will divide it by 10 power 6, 1 2 3 4 5 6, so it will be 16.2. It will be 16.2 kilometer square. This you need to understand. 1 kilometer square equals 10 power 6. Sir, 1 kilometer square equals 10 power 6 meter square. Okay, and 1 hectare is 10 power 4 meter square. This you need to remember. Okay, both these things you have to remember. So area is equal to 16.2 kilometer square. Okay, I hope you are getting the right answer. Perfect. Everyone is getting the right answer. Now let us move on to the second part. Now this was your case 1. Now we will apply the same concept. Okay, we have this concept of volume direct runoff. Now we will apply it in case 2. So case 1 is clear. Everyone kindly comment yes or no. Is case 1 clear to you? Everyone kindly comment yes. Then we'll move on to case 2. Okay, now we'll move on to case 2. Yes, sir, we can move on to case 2. No problem in this one. Yes, now we'll move on to case 2. Now we will move on to case 2. In case 2, see, case 1 is triangular DRH. Case 2 is trapezoidal DRH. Case 2 is trapezoidal. Case 2 is trapezoidal DRH. Okay, sir, in trapezoidal case, In trapezoidal case, so let us say this is my trapezoid. Let us say this is my trapezoid. So then what will happen here? Okay. Let us say this is the trapezoid. Okay, sir. The time base is, let us say, T2 here. Here the base is, let us say, T1. And let us say this is the peak discharge. Let us say this is the peak discharge QP. Okay. So again, I will use the same concept. See, again, I will use the same concept. Area under DRH is equal to catchment area into effective rainfall depth. Again, I will use the same concept. Area under DRH is equal to catchment area into effective rainfall depth. Okay. Yes, sir. I will use again the same concept now. So if I will use this, if I will put the value of values, how you will find the area? Sir, area is half into sum of parallel sides. Half into sum of parallel sides. Sum of parallel sides is T1 plus T2. See, these are parallel sides into distance between them. Into distance between them, which is QP. So this is the area. Sir, this will give me the volume of direct runoff. Yes or no? This will give me the volume of direct runoff. Yes or no? Yes, sir. Perfect. This will give me volume of direct runoff. See, you can simply find the volume of direct runoff like this only. So this is the formula. This is the formula which we have to remember. Or we can, with the basic knowledge also, we can derive this formula and solve it. Okay. So now we'll see one example. Now we'll see one example. As we have seen it here, we'll see one example here also. Okay, we will see one example here also. So a trapezoidal DRH is given to you in the question. A trapezoidal DRH resulting from 2 centimeter rainfall, resulting from 2 centimeter rainfall over, okay, resulting from 2 centimeter rainfall with an average loss rate of 0.25 centimeter per hour. Okay. If duration of rainfall is 4 hours, if duration of rainfall is 4 hours and catchment area is 150 hectares, find the peak discharge. Find the peak discharge. Okay. And see, this trapezoidal hydrograph, this trapezoidal hydrograph thing is given to you. This is your trapezoidal DRH which is given to you. They have given to you in the question. So you can see this figure. Okay, this is 48 hours. Okay, and this is 4 hours. This is 4 hours only. Okay, so you need to find the peak. You need to find the peak here. Tell me. So how I will do this? Sir, I have to simply apply this formula, nothing else. Tell me what is the peak discharge you are getting here. Tell me what is the peak discharge which you are getting here. Tell me. What is the peak discharge that we'll be getting here? Sir, first of all, we have to find the area under this DRH. Okay. Sir, first of all, we have to find the area under this DRH. So area under this DRH will be half into sum of parallel sides. Sum of parallel side is T1 plus T2 into peak discharge. Okay. See, T1 plus T2, we will put the value directly. So T1 is, sir, 48 and this is 4 hours. Okay. So we'll sum up 48 and 4. But one thing you need to make sure, we have to convert this R thing into second. Okay. We have to convert this R into second. So we will multiply it by 60 into 60. We have to convert this R thing. We have to convert this R thing into second. Okay. So we will multiply it. So we will multiply it. Okay. We will multiply it. Is equal to catchment area. Catchment area is how much? Tell me catchment area is how much? Sir, 150 hectares. So I will write 150. Hectare means 10,000 meter square. You all know that 1 hectare is 10 power 4 meter square. So I have written this only. Now at last we have to put the effective rainfall depth. At last we have to put the value of effective rainfall depth. Now effective rainfall depth we can evaluate. Okay, we can evaluate it here. We can evaluate effective rainfall depth here separately. See, effective rainfall depth will be how much? Sir, effective rainfall depth is total precipitation minus infiltration. Now total precipitation is 5 centimeter. Total precipitation is 2 centimeter. Total rainfall is 2 centimeter. Average loss rate is 0.25 centimeter per hour. 0.25 centimeter per hour water is getting lost every hour. So obviously in 4 hours, how much water will be lost? Tell me. Precipitation is 2 centimeter. Loss rate is 0.25 centimeter per hour. In 4 hours, how much water will be lost? When we will multiply in over 4 hours, or 1 centimeter water will be lost. Okay. Subtract it. You will get effective rainfall depth equal to 1 centimeter. Yes or no? Perfect. 1 centimeter. Now put this 1 centimeter here. Put this 1 centimeter here. So we have to convert 1 centimeter into meter like this. Now we will find the value of QP. So when you will solve from here, you will get the value of QP as, tell me how much you are getting. Yes, this is coming out to be, very small. So what we'll do, we'll change our question slightly. We'll make it kilometer square. Okay. We'll change the question slightly. Instead of hectare, I will write kilometer square only. So because of this, you need to understand, when we'll convert kilometer square into meter square, it will be 10 power 6. So the answer will come. As, yes, dear. Answer will be 0.16 if 150 hectare, but if it is 150 kilometer square, the answer will be 16.025. 0.25 means you can round it off to 0.3 or keep it this only. So answer will be 16.02 meter cube per second. Okay. So this is how you will solve. Yes, 16.02 will be the correct answer now. So this is how you will solve for trapezoidal DRH. Okay. I hope this is very clear to you. Now we'll move on to the third case. Case 1 is fully clear to me. Sir, case 2 is fully clear to me. Okay. In this part, any part can be evaluated. They can ask me QP. Sir, they can ask me catchment area. They can ask me effective rainfall depth. Anything they can ask you to solve. So tell me, second case is clear? Tell me if second case is clear or not. Kindly comment yes or no. Kindly comment yes or no. Then we'll move on to the case 3. Okay, sir. Okay, sir. Now we'll move on to the case 3. See, the case 3 is in which no shape is formed. Okay, neither it is a triangle nor it is a trapezoid. Okay, neither it is a triangle nor it is a trapezoid. Only ordinates are given to you. Okay, let me write DRH with ordinates. DRH with ordinates. Ordinate means discharge values. Ordinate means the value which is on y axis. Obviously on y axis, sir, we have discharge. Obviously, sir, on y axis we have discharge. Yes or no? So on y axis we have discharge. So obviously that DRH with ordinates, the value on y axis is given to me. DRH with ordinates is given. Okay, it will be something like that. If you will draw it, you need to understand if you will draw it. See, this is little tough. So in this thing, we will have a hydrograph in which some points will be given to me. So 0, 5 meter cube per second, 10 meter cube per second, like this and this. Okay, few points will be given to me, sir. Few points will be given to me. Yes or no? So what I will do, if few points are given to me, sir, what I will do, okay, sir, if points are given to me, what I will do, now I have to divide, I have to use these ordinates. Okay, I have to divide this hydrograph. Let me write in the steps here. Okay, see, we have to divide the hydrograph. We have to divide the hydrograph into n segments, into n trapezoidal segments, into n trapezoidal segments. Okay, so what we have to do, sir, we have to make out trapezoids into n trapezoidal segments. Okay, so let us say this value is q naught, which is 0 in this graph. Let us say this value is q1. Let us say this value is q2. Let us say this value is q3. This value is q4, and so on so forth. Okay, like this you have n values. So what I will do, I will make first segment, I will make second segment, I will make third trapezoid, fourth trapezoid, like this. I will break this entire hydrograph into small trapezoids. Okay, I will break this entire hydrograph into small trapezoids. Very simple thing. Then what I will do? At the end, I will do what? Sir, I will find the area under DRH will be equal to what? Catchment area into effective rainfall depth. Yes or no? Now, how to find the area under the DRH? Okay. See, area under the DRH will be, if you want to find the area under this DRH, what I will do, we have divided this entire hydrograph into n segments. Okay. So this is your first segment. This is your second segment. Okay, like this. Okay, let us say this is time t1, gap is 1 hour, or let us say this is t1 t2, like this. Okay, time is also given to you, no problem. So what I have to do, I have to find the sum of all the areas. I have to find the sum of all the n segments starting from 1 to n. I will find the, see, let us imagine this is the middle trapezoid. The area of this, how you will find the area of this? Sir, the area of this I will find simply half into sum of parallel sides, which is q2 plus q3. Half of sum of parallel sides, which is q2 plus q3, into distance between them, into time between them. Time between them is, let us say, t. t3 minus t2, let us say it is t. So what I will do here? Sir, if I want to find the area under the DRH, what I will do? I will simply do find the area of half into qi plus 1, half into qi plus I plus 1. If this is Q naught, so this is Q1. If this is Q1, so this is Q2. If you want to find the area of this trapezoid, this is Q1, this is Q2. Okay. So if this is I, this is I plus 1 into the time gap, into the time duration between it. Okay. Into the time duration, which is, let us say, T2 minus T1, or let us write here Ti plus 1 minus Ti. Like this, we will find the total area. Like this, we'll find the total area and get the volume of direct runoff. So this is the main formula here. So this is the main formula. Okay, we will use this concept here. We will use this concept here. Okay, sir, no problem. So we will use this concept here. Okay, so this is the case 3 in which my DRH is divided into n segments. In which, sir, my DRH is divided into n segments. Okay, we will solve one question. 2 questions have been formed in your examinations from this topic. Okay, 2 questions have been asked. 2 questions from this topic has been asked in your examination. Okay, so I will give you the very first example of this case. So in the example, a DRH resulting from a DRH resulting from 3 centimeter direct runoff, 3 centimeter direct runoff starting from a DRH resulting from 3 centimeter direct runoff starting from 2 p.m. A DRH resulting from 3 centimeter direct runoff starting from 2 p.m. Okay, a DRH resulting from 3 centimeter direct runoff starting from 2 p.m. has its ordinate ordinates as 0, 5, 12, 25, then we have 17, then 9 and 0 meter cube per second. So these are the different ordinates which are given to you. Has its ordinate as at 60-minute interval. At 60-minute interval. At 60-minute interval. Okay, at 60-minute interval. So this is your oral question. Now they are saying in this question we have 2 parts. They are saying find the volume of direct runoff, the first part. They are saying us to find the volume of direct runoff, and secondly they are saying us to find the catchment area. Okay, secondly they are saying us to find the catchment area. Yes, so now how I will do it. Okay, so if we want to draw this hydrograph, see they are saying 0, 5, 12, all these values are given to me starting from 2 p.m. at a gap of 60 minutes. So if I will draw this graph, so if I want to draw this graph, it will be somewhat like this. Sir, it will be somewhat like this. Okay. Sir, we have 0, 5, 12, 25, 17. Sir, we have 0, we have 5. See, this is 0, this is 5. We have 12, 17. We have 0, 5, 12, 25. Okay, we have 0, 5, 12. Then we have 25, 17. Then we have 9. Then we have 9. Then we have 0. Like this we have. So this is your first. See, we have to join them using straight lines, obviously. Okay, we'll join them like this. Okay, we'll join them. They are joined like this. So this is your first, this is your second trapezoid, this is your third trapezoid. Like this, you have different trapezoids. Okay, starting from 2 p.m. is, this is 2 p.m. This is 2 p.m. So 60-minute interval, this means this is 3 p.m. This is 4 p.m., 5 p.m., 6, 7, and 8, like this. Okay. These values are 0, 5, 12, 25, 17, 9, and 0. Okay. So discharges are given to me. Now how I will find the area? If I want to find the area, under this DRH, see, if I want to find volume of direct runoff first, sir, if I want to find volume of direct runoff first, so volume of direct runoff will be what? Area under DRH. How I will find area? Sir, how I will find the area? See, if you want to find the area, you have to find the area of these trapezoids. First, you will find this area. Half into sum of parallel sides. Half into sum of parallel sides, which is 0 plus 5 into time gap. Time gap is, see, if you want to find this area, it is half into 5 plus 0. Gap is 1 hour. Gap is 1 hour. Okay. Gap is 1 hour. So this is in meter cube per second. This is 1 hour. Plus half into, this is the area of first trapezoid. Okay. This is the area of first trapezoid. Now the second trapezoid, you must be wondering, sir, this is not trapezoid. This is a triangle. So basically triangle is a kind of trapezoid only. Okay. Imagine this is a trapezoid which with 0 side, and this is your 5. So half into 5 into 1, that you can also do directly, no issues. Now the second trapezoid is 5 plus 12. Sum of parallel side is half 5 plus 12 into distance between them. Distance between them is again 1 hour. Time gap is 1 hour. Okay, like this you will find all the areas. Then the third trapezoid is having area how much? 12 plus 25. 12 plus 25 into 1. Then half into sum of parallel sides 25 plus 17 into 1. Then sir, half sum of parallel side is 17. See, this was the fourth one. Now the fifth one, and lastly the sixth one. We have 6 segments. So the fifth one is 17 plus 9 into 1. At last we have half into 9 only. 9 plus 0 into 1. So tell me how much we are getting. If we will solve this, sir, if we will solve this, see, one thing is also there. See, you can see one thing here. If you will take half common, and if you take 1 common, 1 hour. Okay, if you take this 1 hour, see, you can see one thing, that this time duration in all the trapezoids is same. 1 hour, 1 hour, 1 hour, 1 hour, 1 hour. It is same in all this. In all the cases, sir, time gap is same in all the cases. Okay, that is 1 hour, 1 hour. Okay, so if we take half and 1 hour common, what we are getting inside? What we are getting inside? Sir, we are getting this 5 2 times. We are getting this 2. See, let me write it here. 0 plus 5 plus 5 plus 12 plus 12 plus 25 plus 25 plus 17 plus 17 plus 9 plus 9 plus 0. This we are getting. Okay, so if you will simplify it, see, all the values are coming. See, ignore the first 0 and last 0, but all the middle values are coming 2 times. All the middle values are coming 2 times. So I will write 2 times 5, 12, 25, 17, and 9. 9 is also coming 2 times. All the values are coming 2 times. Yes or no? Solve this. How much we are getting? If you will sum up, sir, if we will sum this up, we will get it as half into Yes, we are getting it as 68. This is coming out to be 68. So this 2 and 2 will get cancelled. You need to understand all these things. This is what? Sir, listen very carefully. This is what? Sir, this is sum of ordinates. See the question to me. The question is given to me as 0, 5, 12, 25, 79. So you can see here 0, 5, 12, 25, 79. We have simply summed up all the ordinates. We have simply summed up all the ordinates and multiplied by time. Half and half, this half and 2 has got cancelled, and multiplied by the time gap. Okay, so we will simply do the summation from I equal to 1 to n. Like this also you can directly get the volume. So remember this formula also. Okay, sir, this will give me what? Volume of direct runoff in case of, sir, this will give me volume of direct runoff in case of, sir, in case of this one, sir, in case of DRH with where ordinates are given to me. Okay, so you can do this thing. Okay, sir, no problem. They are saying find the volume of direct runoff. They are saying to me that find the volume of direct runoff. So what I will do, I will find this. See, this is 1 hour. This is 68. See, this is 68 meter cube per second. This is 68 meter cube per second. So I will multiply this by 1 hour. 1 hour is 3600 second. Sir, 1 hour is 3600 second. Yes or no? So I am getting the volume of direct runoff as 244,800 meter cube. Okay, when you will solve it, the first part is coming to be, okay, we'll write it, don't worry. So first part is volume of direct runoff, which we are getting it as 244,800. Okay, this is volume of direct runoff only. Second part is find the catchment area. So we will do what? So volume of direct runoff. So volume of direct runoff is equal to catchment area into effective rainfall depth. Volume of direct runoff is coming out to be 244,800. Area we want to find out. Effective rainfall depth is given to me in the question, which is 3 centimeter. Direct runoff is 3 centimeter. So I will put here 3 centimeter. Convert this 3 centimeter to meter. Get the catchment area in meter square. How much we are getting? 816 4 times 0. We are getting this area as 816 4 times 0 meter square. If you want to write it in hectare, divide by 10 power 4, you will get 816 hectare. If you want to write this in kilometer square, divide by 10 power 6. Divided by 10 power 6, you will get the area 8.16 kilometer square. Okay. Yes. 8.16 kilometer square. So like this, you have found out the catchment area also and your volume of direct runoff. So this is your part 1. So this is the part 1. And sir, this is the part 2. So I hope these kind of questions are clear to you. See, these type of questions have been asked in your gate examination. Okay. These types of question has been framed in your gate examination. So I hope such kind of examples you can easily solve. So tell me if all the cases are clear to you. Tell me if all the cases are clear to you, and also write this shortcut. Okay. Also write this shortcut method. It can be useful. And also you need to remember one thing. See, simply sum of the ordinates and multiply it by time only when all the times are same. See, this is 1, this is 1, this is 1, all are same. Then only you can take it out common. If this is 1 and this is 2, then you cannot take it out common. Okay, then this formula will not be valid. Okay, so you can take it out common only when we have all the time gaps same. Okay, then only I will use this trick. Let me drink water, then I will start. Yes, you can write in bracket constant duration. Perfect, dear. We can write constant duration. Yes, we can write here. We can write here constant duration. We can write constant duration between ordinates. Otherwise, if duration between ordinates is not constant, then what I can do, sir? Then simply I can use this. Okay, I will simply find the area of each and every segment using the trapezoidal formula. No issues. Okay. Okay, sir. I have understood all these cases very clearly. So from this concept, three kind of questions are framed in your GATE examination. Three kind of questions. The very first one is they will give you a triangular DRH. Sometimes they will ask you to find the area. Sometimes they will ask you to find the effective rainfall depth. Okay, in this, use this equation and get the answer. Okay, use this equation simply. Secondly, they will give you a trapezoidal DRH in which they will sometimes ask you effective rainfall depth. Sometimes they will ask you to find the area. Sometimes they will ask you to find the peak discharge, like this. And sometimes they will give you DRH with different ordinates where you have to use this concept. Okay, so all these things will be given to you and you can simply use it and get the answer. So ultimately we have understood how to find the volume of direct runoff. So volume of direct runoff is nothing but area under my DRH. I have to simply find the area under direct runoff hydrograph. That will be the volume of direct runoff. Okay. Yes. Perfect. Now what I have to do, sir? Now what I have to do? So I was telling you how to obtain effective rainfall depth. How to obtain effective rainfall depth from flood runoff hydrograph. Okay, from FRH, how you will obtain effective rainfall depth. This I was telling you. So now you have understood the concept of volume of direct runoff. Now I have, sir, understood this concept. So now if you have understood this concept, now I will use this one. Okay, then I will use this one. So what I have to do now? Obtain DRH from FRH by DRH equal to FRH minus base flow. Okay, sir, clearly understood. Now what else? After this, I have obtained the DRH. Find the volume of direct runoff. See, you have obtained the DRH now. You have obtained the DRH. Let us say you have obtained the DRH with some different points. I have told you if you have got the DRH with different points, how you will find its volume. Case 3. If you have got the DRH, you can simply find the volume of direct runoff. If it is trapezoidal, no problem, sir. If it is triangular, no problem, sir. If it is n segmented, then also no problem. So find the volume of direct runoff. By evaluating area under DRH. By evaluating area under DRH. Okay, sir. What else? After that, what I have to do? So after this, I have the volume of direct runoff. Now, effective rainfall depth, if you want to find out, what you have to do? You have to simply divide volume of direct runoff. You have to simply divide volume of direct runoff by the catchment area. So if you want to find the effective rainfall depth, you have to divide volume of direct runoff by catchment area to get the effective rainfall depth. Okay, you have to divide the volume of direct runoff by the catchment area. Simply you will get the effective rainfall depth. Simple question, very basic question. See, if you want to find, let us say in this example, in this one only, let us say we have a triangular DRH. Okay, sir, we have DRH area also. We want to find effective rainfall depth. How I will do? Sir, I will divide this volume of triangular. I will divide this volume of direct runoff by the catchment area. I will divide volume of direct runoff by catchment area to get the effective rainfall depth. Yes or no? Yes, simple. Perfect, perfect, dear. Okay, so this is simple thing. I hope it is clear to you. Now we'll move on to another concept. Now we'll move on to one more concept here. See, solve this question. This question has been asked in your GATE examination previous year. This question has been asked in your GATE examination. Let me see how many of you can solve this one. Okay. Try to solve this one. Let me see if you are able to get the correct answer A, B, C, D. I am giving you 1 minute's time. I am giving you 1 minute's time. Check it. Yes, tell me how much you are getting. You are getting option A. Perfect. You are getting option A. Great. So simply it is triangular. I will use the direct formula. Sir, half into QP into TB. Sir, half into QP into TB is equal to catchment area into effective rainfall depth. I want to find this. Sir, catchment area is, everything is given to me. Peak flow rate is 30 meter cube per second. I will write QP 30 meter cube per second. Sir, base time is how much? 80 hours. Convert this 80 hours into seconds. Okay, second will get cancelled. Catchment area is how much? 86.4. So 86.4 into 10 power 6 meter square. I will get the effective rainfall depth. When you will solve it from here, you will get effective rainfall depth as 0.05 meter. And if you will convert into centimeter, it will be 5 centimeter. Yes, you are getting the correct answer. You are getting the absolutely correct answer. Perfect. Now, one more question has been asked in GATE examination. Okay, this question has also been asked in your GATE examination. Okay, sir. So tell me ABCD, which option is correct here? Tell me. This question is also has also been asked in your GATE examination. This is 70. This is 4 hours. This is 90. Okay, find the area in a square kilometer. I am giving you 1 minute's time. Solve it quickly. After this, we'll move on to the next concept. Very important one. After this, we'll move on to the new concept. Are you getting it? 599.4. Okay, great. 599.4 is perfect. So half into QP. QP is 90 meter cube per second into sum of parallel sides, which is 4 plus 70. So 70 plus 4 Rs. You need to convert this R into second. This will be equal to catchment area into effective rainfall depth. Effective rainfall depth is given to me as 2 centimeter. Convert it into meter. So from here you will get the area as 5994, something like that, kilometer square. So you will get it as 599.4 into 10 power 6 meter square. So when you will convert it into kilometer square, you will get it as 599.4. Okay. So this is your answer. That means B option is correct here. Okay. Yes, B option is correct here. Perfect. So you are able to solve the gate questions now. Now we'll move on to the next concept. Which is, see, the next concept we will understand when we'll try to cover unit hydrograph first. Now the next concept is of unit hydrograph. Okay, so unit hydrograph is nothing. See, we have understood what is direct runoff hydrograph. Sir, you told me that direct runoff hydrograph has two parameters. Rainfall parameters. Sir, what are those two parameters? The first one is duration and the second one is effective rainfall depth. Now, this duration can be 1 hour, 2 hour, 3 hour, like that. Rainfall duration. And effective rainfall can be 1 centimeter, 2 centimeters, sir, it can be 3 centimeter, like that. But if it is, listen very carefully, if this effective rainfall depth is 1 centimeter, then I will call that hydrograph, direct runoff hydrograph as, tell me, if effective rainfall depth is equal to 1 centimeter, then I will call this direct runoff hydrograph as, yes, tell me. So unit hydrograph means it is a direct runoff hydrograph. It is a direct runoff hydrograph. Resulting from 1 centimeter direct runoff or 1 centimeter excess rainfall. Effective rainfall, excess rainfall, all are one the same. Resulting from 1 centimeter excess rainfall, occurring in dr duration. Okay. Yes, it is called unit hydrograph. So see, they will give you like this. They will give you 1 hour unit hydrograph. They will give you 2 hour unit hydrograph. Listen very carefully. They will give you 2 hour unit hydrograph. They will give you 3 hour unit hydrograph, like this. Like this, so on and so forth. You will have dr unit hydrograph. Okay, what is the meaning of dr? See, sir, you need to understand the first parameter duration is different. Duration can be 1 hour, 2 hour, 3 hour, like this. Okay, sir, I will write here one thing, that 1 centimeter effective rainfall depth occurred in 1 hour. Sir, here I will write, sir, again 1 centimeter. See, unit hydrograph means, unit means what? Unit means 1 centimeter excess rainfall. So 1 centimeter effective rainfall depth occurred in 2 hour. Here I will write, sir, 1 centimeter effective rainfall depth occurred in, tell me. Sir, 1 centimeter effective rainfall depth or excess rainfall occurred in 3 hour. Sir, here 1 centimeter effective rainfall depth occurred in dr, like this. So this unit is representing effective rainfall depth, and this d is representing duration. This d is representing duration. Here intensity will be what? Sir, in this one, intensity of effective rainfall intensity is, sir, in this effective rainfall intensity is, if you want to write effective rainfall intensity, how you will write? See, 1 centimeter in 1 hour. So I will be 1 centimeter per hour. Here it will be depth upon duration. So 1 by 2 centimeter per hour. Here it will be, sir, 1 centimeter in 3 hour. So duration, effective rainfall intensity will be 1 by 3. Effective rainfall intensity here will be 1 by d centimeter per hour. 1 centimeter in d hours. So that will be your effective rainfall intensity. Hello dear. That will be my effective rainfall intensity. Okay, so this is your unit hydrograph. I hope unit hydrograph is clear to you. Ankit is saying I have not understood. So what you have not understood, Ankit? Ankit, tell me what you have not understood. Ankit, listen very carefully. See, have you understood all the concepts which you have discussed earlier? Tell me, have you understood all these concepts? Have you understood that my direct runoff hydrograph can have two parameters, duration and effective rainfall depth? Have you understood this thing? Tell me, if effective rainfall depth is 1 centimeter only, then I will call this direct runoff hydrograph as unit hydrograph only, nothing else. Okay, then I will call this direct runoff hydrograph as unit hydrograph. See, sir, simply you are saying that unit hydrograph is also a DRH. Unit hydrograph is also a DRH, but we can say, sir, it is 1 centimeter DRH. Sir, it is 1 centimeter DRH in which excess rainfall depth is 1 centimeter, which is occurring in DR. DRs. Yes or no? How to, which is occurring in DR. So this is your unit hydrograph. This is the main concept. Now, sir, why we are studying this? The concept is why we are studying is, see, basically you need to understand, if we have the effect of unit hydrograph, see, you need to understand one thing. Now let us say you have unit hydrograph. Now let us say, let me take an example with the help of which you will understand. Let us say we have a unit hydrograph, and the peak of this unit hydrograph, let us say, is 15 meter cube per second. Okay, and let us say this is 6 hour. Let us say this is 6 hour unit hydrograph, which means effective rainfall depth is 1 centimeter. Now the question is, in actual, sir, this is my 6 hour unit hydrograph, okay, which you can find out in National Institute of Hydrology. In Roorkee it is, okay. This is an institute where you will get, basically you will get all the hydrographs of all the catchment areas in India. In India, you all know that every river has a great catchment area, and all those hydrographs or all the catchment areas you will find in the institute. Okay, so now you need to understand one thing. Yes, sir. So because of this 1 centimeter excess rainfall, tell me, because of this 1 centimeter excess rainfall at the outlet, the discharge is 15 meter cube per second. Yes or no? Because of this 1 centimeter excess rainfall, sir, this excess rainfall is 1 centimeter. Because of this excess rainfall 1 centimeter, sir, the peak discharge is 15 meter cube per second. Now the question is, if we have 6-hour rainfall, sir, if we have 6-hour rainfall and we have evaluated effective rainfall depth as 5 centimeter, or let us say, yes, let us say 5 centimeter, then what will be the peak discharge? Then what will be the peak discharge? Can you guess it? Can you guess it? Sir, if because of 1 centimeter effective rainfall depth, if because of 1 centimeter effective rainfall depth, the peak discharge is 15. Okay, sir, here also rainfall duration is 6 hour. Here also rainfall duration is 6 hour. Here the effective rainfall depth is 1 centimeter. Here the effective rainfall depth is 5 centimeter. Sir, here the peak discharge is 15. So here the peak discharge will be. Can you guess it? Can you guess it? Try to tell me. Try to tell me what will be the peak discharge here, sir. Sir, if because of 1 centimeter the peak discharge is 15 meter cube per second, if 1 centimeter excess rainfall, if 1 centimeter direct runoff is there, then in the catchment, at the outlet, the discharge is 15 meter cube per second. Now, if rainfall increases and we have 5 times the intensity, and if we have 5 times the runoff, then obviously this discharge will increase 5 times. Okay, we will have it as 75. Yes, yes, you are getting it absolutely correct. Perfect. So this is the use. This is the use. Basically, this is the use of your unit hydrograph. Okay, in unit hydrograph, we have certain assumptions. Okay, so yes, you are right. Here the discharge will be 75. But how you have guessed it? Okay, we have different applications of unit hydrograph which we'll discuss. There is no issues in that. But yes, first we'll understand what are the assumptions of unit hydrograph. Okay. So in unit hydrograph theory, we have certain assumptions. Yes, in unit hydrograph theory, sir, we have certain assumptions. Now we will understand the assumptions one by one. 4 assumptions are there, after which we will end our class. Okay, we'll understand all the 4 assumptions one by one. Okay, we need to understand the 4 assumptions. Very simple assumptions. The very first one is, the very first assumption is in unit hydrograph that effective rainfall should be uniformly distributed. The effective rainfall should be uniformly distributed over the basin. Should be uniformly distributed over the basin. Okay. This simply means that this is your catchment area and you have different rain gauges. So all the rain gauges should receive almost the same kind of rainfall. Okay, this assumption means the rain gauges, in basin, should receive almost same amount of rainfall. Almost same amount of rainfall. Okay, so this is the first assumption. Only 4 assumptions are there. You need to understand. This is the first one. Okay, this is the first one. The second one is effective rainfall is constant. Effective rainfall is constant constant over the catchment. Effective rainfall is constant over the catchment, during the during the during the unit time. Unit time means intensity. See, if you are having effective rainfall depth as d and you will divide by time, then obviously it will be intensity. Okay, unit time means what? When you will divide by time, you will get effective rainfall intensity. That is effective rainfall intensity. That is effective rainfall intensity. Effective rainfall intensity is constant. Okay, we are not having complex storm, sir. We are having a simple storm in which effective rainfall intensity is constant. So this is your second assumption. Now the third one. Third one is important, which is known as time invariance. This can be asked in your examination directly. So what is the meaning of time invariance? See, in time invariance, you need to understand, no matter whenever your rainfall happens, if it will happen, the shape of hydrograph will be same every time. This is the meaning. See, let me explain it to you first, then I will draw it. I will write the point. See, let us say this is the rainfall. Let us say this is your rainfall. Let us say rainfall has happened for dr, and because of this rainfall, we have a DRH like this. Okay. Let us say after some time, again this kind of rainfall has happened, similar kind of rainfall of same effective rainfall depth, same duration, everything is same. So when you will again receive such kind of excess rainfall, the shape of this hydrograph will be same. Okay, like this. Yes or no? This is the meaning of time invariance. You will get the same kind of DRH again. Okay, no matter whenever your rainfall happens, but whenever it will happen, sir, we will have the resulting DRH same. Okay, resulting DRH will be same. So I will write the DRH for a given effective rainfall. The DRH for a given effective rainfall for a basin. Is always the same. Irrespective of when it occurs. No matter, sir, whenever it occurs, but the graph shape will be same. Okay, but you need to understand the total duration and the effective rainfall depth. Has to be same. Effective rainfall depth and duration has to be same. Let me write here this point. It will be same when duration and effective rainfall depth is same. So duration and effective rainfall depth is same, then you will say that every time you will get the same shape. Then you will say that I will get the same shape every time. Okay, but this is actually not the case. Actually, you will see that obviously if rainfall has happened once, then obviously in the second time less infiltration will be there, because already ground has absorbed some moisture, so more runoff will be there. In the second rainfall, see, first rainfall more water will go into the ground, but when second rainfall will happen after the first rainfall, then obviously more runoff will be there because less water will go into the ground. Okay, so second time when rain will happen, you will see you will see that more runoff will be there, and because of this the hydrograph should have increased, but we are assuming it to be same. So this is the assumption. This is the assumption. Now the last assumption. This is the assumption number 4, which is linear response. The most important, without which we will not be able to understand hydrograph properly. So this linear response means the ordinate of DRH, the ordinate of DRH is proportional to effective rainfall depth. DRH ordinate means discharge. Okay, is proportional to effective rainfall depth. Okay, let me write it here. Let me write it here that the discharge, which is a function of time, discharge which is a function of time, is proportional to effective rainfall depth. This is the main concept. This is the main concept here. Okay. So let us take an example. Let us say we have input. See, these are inputs. Okay, these are inputs, and let us say because of this input, because of this effective rainfall depth, because of this rainfall, we have output hydrograph, we have output discharge, let us say y1. Okay, y1 means ordinate. You all know that if we have, sir, 1 centimeter rainfall, then this is the curve. If we have 2 centimeter rainfall, then obviously the curve will be double like this. Okay, so if this is the input and this is the output, again let us say we must take one more value here. Let us say in the second case we have this as input and output is, and let us say now output is y2. Now output is y2. So what is the significance of this? See, the significance of this is if you will add both of them, if we will add, these are your effective rainfall depths and these are the discharges which are which you are getting because of these effective rainfall depth. Now if you will do the sum, of effective rainfall depths, then the output will automatically be the sum. Okay, then the output will automatically be the sum. If you will multiply this input, let us say you will multiply it by r times. Okay, if you will multiply it by r times, then the output will also be multiplied by r times. Why? Because of linear response. Sir, how I have said, see, you have asked me one question, sir. You have asked me one question that if 1 centimeter effective rainfall depth, this is the input. If 1 centimeter effective rainfall is there, then the peak discharge is 15 meter cube per second. Yes, sir. Now, if effective rainfall depth is 5 centimeter, then what is the discharge? Then what is y2? Sir, what I have done, I have simply multiplied by 5. Why? Because of linear response. Because I know when your because I know that discharge or the value on the y-axis is proportional to effective rainfall depth. If effective rainfall depth will be doubled, if effective rainfall depth is doubled, discharge will be doubled. If it is tripled, it will be tripled like this. If it is made r times, sir, if this is made r times, output will be made r times. Okay, if because of 2 centimeter we have 30 meter cube discharge, and if because of, let us say, 5 centimeter we have because of 2 we have 30, so because of 5 we have 75. So obviously for 7 centimeter you have, sum it up, you have 105 meter cube discharge. How? Because of linear response. Okay, so because of linear response, sir, we can sum it up, we can multiply. Okay, but yes, one thing is constant here, which is rainfall duration. Okay, sir, we have to make sure that in both the examples 6 hour rainfall is same. Okay, 1 centimeter will give you certain discharge, then obviously 5 centimeter will give you 5 times discharge, but the rainfall duration should be constant. This you need to understand. Rainfall duration is constant. rainfall duration is constant. So you can simply do proportional things, you can sum it up, you can do superposition. Why? Because of this property, because of this assumption. Okay. So when effective rainfall depth will increase, my discharge will also increase. This we have understood clearly. This we have understood clearly. Okay. Yes or no? Tell me. Sir, if this is the last point, let us say, sir, this is the, let me say this is 1 centimeter DRH of 2 hours. Let us say this is 1 centimeter DRH of 2 hour. That means in 2 hour rainfall was there, and because of that 1 centimeter excess rainfall is there. So tell me, let me draw 1 centimeter here. This is 1 centimeter. Now let me double the rainfall. So if rainfall is getting doubled, so now let me say rainfall is getting doubled, total 2 centimeter, then the graph will be just doubled. Just double of this. Simply increase the ordinates. Okay, discharge will be doubled. So this will be what? So this will be 2 centimeter DRH. This will be 2 centimeter DRH of 2 hour only. Duration will be same, but just you will see that discharge will be doubled. Discharge will be double of same shape. Okay. Yes or no? So this is the meaning of linear response. Linear response is very, very important. Okay, without this method of superposition and nothing will be possible. Tomorrow's class will be based on all these assumptions only. So in today's class, basically we have discussed the assumptions. We have discussed what is linear response, time invariance, effective rainfall should be uniform, effective rainfall intensity should be uniform, all these things should be uniform. Then unit hydrograph we have discussed, and we have solved the basic concept of how to find the area under DRH, that is volume of diet runoff. Okay, we have discussed this concept today mainly. So I hope everything is very, very clear to you. With this we will end our session today. Okay, with this we are going to end our today's session. So have you understood the entire concept? Have you understood the entire concept? Tell me, have you understood the entire concept of unit hydrograph and all these things? Yes. So basically, so we have understood it. I hope it is clear to you. So thank you everyone. Yes, you will get the notes on PW app. Okay, you will get the notes in PW app. Okay, simply go to PW app. There in the free section you will get these notes. So thank you everyone. Stay blessed. Take care.